Hi guys, so today we're going to be learning about how to prove triangle congruency. This is just an introduction. It's not in your book, but it will help you as you do the next two lessons on proving triangle congruency. Okay. So a lot of times people are a little bit confused about triangle proofs, but it's actually quite simple. And the reason why is because there really is only 5 ways to prove triangles are congruent. And these are the 5 ways listed here. Okay. So the first one is side, 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 congruence postulate. If 3 sides of one triangle are congruent to 3 sides of another triangle, then the triangles are congruent. Okay. So with side, 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 it's because one side is congruent to one side. A second side is congruent to a second side. And then a third side is congruent to a third side. And so that's what side, side, side congruence postulate is. Okay. The next one is side angle side congruent postulate. Basically, it says that if 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of another triangle, then the triangles are congruent. Okay. So then first, one side is congruent to one side. So here, this side is congruent to this side. Okay. We also have another side congruent to another side. Okay. And when it says included angle, it means the angle that is in between those two sides. Okay. So here it has to be this angle. This is the included angle because it's in between these two sides that we're talking about. For this triangle, this would have to be the included angle because it's the angle that's in between those two sides. Okay, so keep that in mind. That is important. That angle that we're talking about that's congruent has to be the included one, the one between. Okay. Our 2 other ways of doing it is angle side angle and angle angle side. Note that both of them have 2 A's and only 1 S. But the difference between them is their order and therefore what will show up. Okay, so here, angle side angle, we have one angle congruent to one angle. We have another angle congruent to another angle, right? And then the side that we're talking about in angle side angle it's the included side. It is the side that's in between the 2 angles that we're talking about. Okay. That's what makes it different from angle angle side, because in the same way we have 2 angles that are congruent. However, the side here, rather than being the included side, the side that's in between these 2 angles, it's the side that comes immediately after, right? So pink, yellow, and then the side immediately after. Pink, yellow, the side immediately after. Okay, so that's the difference. Okay, it's where that side is, whether it's the included side or the one that comes right after the angle. Okay. The other one here is hypotenuse leg. This one only works for right triangles because only right triangles have a hypotenuse. Okay? And what it says is that if the hypotenuse and the leg of one of the right triangles is congruent to the hypotenuse and leg of another one, then the triangles are congruent. Okay? So hypotenuse is the side across from the 90 degrees, so that would be this and this. So if the hypotenuses are congruent and one of the legs are congruent, okay, then the triangles are congruent. Okay, this is a shortened version of side, 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 because using the Pythagorean theorem, we can figure out what the other side is, and based off of that, they would have to be the same thing. Okay, and then so here, just a reminder again, an included side is the common side of 2 consecutive, meaning follows after the other angles in a polygon. So an example here is segment PQ is the included side of angle P and angle Q, right? So one in between. Okay. versus the included angle is the angle that's in between those two sides. So an example is angle P here is the included angle of sides PQ and PR. It's in between PQ and PR. Okay, so now with that in mind, what we're going to do is based off of the information we're given here, we're going to determine which of these 5 ways we can use to prove the triangle is congruent. Okay, so we're going to name the postulate or theorem we use to prove that these two triangles are congruent given the following information. If there's not enough information, we're just going to state that there's none. Okay, so we're going to start with this first one. Angle B is congruent to angle Y. So I'm going to do that in pink. Angle B is congruent to angle Y. Okay. Then the next one is angle A is congruent to angle Z. So here's angle A, here's angle Z. Okay. And then the last one tells us that BC here is congruent to YX. BC is congruent to YX. Okay. So here we have to go in order. So this is angle, angle, side. Okay, note the side comes after the two angles, and it's, okay. And so same thing, angle, angle, side. So here, do we have an angle, angle, side? Yes, we do. So angle, angle, side, congruence theorem proves it. Okay, so let's do the next one. Okay, so angle C is congruent to angle X. So angle C is congruent to angle X. Okay. Angle A is congruent to angle Z. So angle A is congruent to angle Z. Okay. And then the third part tells us that CA and XZ are congruent. Okay. And so here, again, going in order then, it's angle, side, angle. And so that is one of our 5 ways of proving congruent triangle. So angle, side, angle, congruence, and this is a postulate. Okay. Note that only AAS and hypotenuse leg, those are the only theorems. The other ones are all postulates. Okay. Now let's do the next one. Okay. AC is congruent to ZX. So AC congruent to ZX. Okay. Angle B is congruent to angle Y. So angle B here is congruent to angle Y. And then the last part is BC is congruent to YX. Okay. So here, this is in order side, side, angle, okay, or ASS, okay. So we do not have a side, side angle or ASS, so that means we don't have enough information to prove that they are congruent. And the reason why is because I can create another triangle that has side, side, and that angle that isn't congruent to this one. Okay? So this one, there's not enough information to prove they're congruent. Okay. So just remember, there is no SSA or, okay, easy to remember. There isn't this. It's a bad word, so we don't say that. So we don't have that. Okay, so that's an easy way to remember that. Okay. Next one here, we have ZX and AC. Okay, so ZX is here, AC is here. Okay. Then we have XY and CB. So XY is here, CB is here. And then we have angle X is congruent to angle C. So angle X is here, is congruent to angle C. And so this going in order is side, angle, side, right? Side, angle, side. And so do we have a side, angle, side? Yes, we do. So this is proven by side, angle, side congruence postulate. Okay. Then here's the next one. Okay. So we have AB is congruent to ZY. So AB is here. congruent to ZY. We have AC congruent to ZX. And then we have CB congruent to XY. And so what do we have here? These are all sides. So this is side, side, side congruence postulate. Okay, last one here before we talk about missing information. So here we have AB is congruent to BC. So AB congruent to BC. So this is congruent to this. Okay. And then here we know that BD bisects this angle. So if this side bisects the angle, that means that this part is now cut into 2 equal halves. So this is now equal to this, okay? Which seems like we don't have enough information. However, what we notice is that they share a side. So that means this side has to be congruent to itself due to the reflexive property, right? And so what that tells us then is now I have side, angle, side. Because I can say that BD is congruent to BD with the reflexive property. So side, angle, side, I can use the side, angle, side congruence postulate to prove that. Okay, cool. So basically what you're doing is when you're proving triangles are congruent, note what information you have. I would mark it in the picture, right? And then note, based on definitions, what can we gather from that? Or do we see any common sides, any vertical angles, things like that? Okay, so now that's going to take us to our next part here. We're going to identify missing information. Okay, so the pair of triangles below has 2 corresponding parts that are indicated here. We're going to state what additional information is needed to prove congruence with this stated postulate or theorem. Okay. So this first one here, one side, angle, side. So I have side, angle, side, angle. So the thing I'm missing is this last side here. So I am missing the part that tells me that DA is congruent to T. This is an O, I think. TO. And that is what I am missing. Okay. Because once I have that, I have my side, angle, side. Okay. So next one here is side, side, side. So note I have side and side, side and side. The one I'm missing is this third side here. Right. I'm missing it telling me that segment EL is congruent to segment KN. Okay. So here we have angle, side, angle. Note that the side is in between, so it's going to be angle, side, and it has to be this angle here. Angle, side, this angle here. And so what I'm missing is it telling me that angle N is congruent to angle M. Okay? This one here is side, angle, side. Note that the angle here is between the 2 sides. It's the included angle. So these are my 2 sides. The angle has to be the one in between them, the included one. So I'm missing this angle here. So that is angle C congruent to angle J. That's the other information I need, right? This one here is angle, angle, side. So no, I already have an angle and a side. So I'm now missing the angle in front of it. So that would be here. So I'm missing the part that tells me that angle A is congruent to angle O. Because then I will have angle, angle, side. Right? So the order matters. Okay? Then the next part is angle, side, angle. Note the side is in between. So here's my angle, here's the side. That means it has to be the angle after that. So this angle, so angle, side, and then this angle here. So I'm missing the information that tells me that angle B is congruent to angle C. Okay? However, if I wanted, I could prove it with side, angle, side, but that's not what it asked for. Okay? So here, when looking to prove congruency in triangles, you want to look for important information, such as reflexive sides, sides that they share, Vertical angles, right? So if you have two triangles that look something like this, right? We already know these vertical angles are congruent, right? So that's one of our A's possibly. Angle pair relationships formed by parallel lines, and other given information based on definitions, such as the word midpoint, segment bisector, or angle bisector, that tells us that it cuts something into two equal halves. Okay. So that's it for this video. You're now going to try some practice similar to example 1 and example 2. And so have a great rest of the day. Bye, guys.